In this lecture, we are going to discuss the analytic epidemiology. In the previous lecture, we have already discussed the descriptive epidemiology, where we discussed the occurrence of disease or describe the occurrence of the disease or distribution of the disease regarding individuals who are affected, where, at what places, and when, at what time. By analytical study, we are going to discuss why individuals develop disease, and by studying the association between risk factors and the occurrence of the disease, so we are going to answer the questions why and how. So at the end of this lecture, the student will be able to describe the difference between descriptive study and analytical epidemiological study in terms of information and evidence proved for medicine and public health. Also, to estimate the difference or variation in the occurrence of disease or health-related events regarding exposure to certain risk factors. Also give explanation for this variation, understand the role of analytic epidemiology in describing the population and helping the exploration of various variation to aid the planning of the health services. And lastly, he will understand the association between risk factors and outcome or disease and the criteria of association. We search for the determinants of health outcomes first. Always, as a public health physician, we are always looking for the causes of the disease. What are the causes of the disease? If an individual exposed to certain factor, what is the outcome of this exposure? So, in the descriptive epidemiology, we have already discussed the matters of the occurrence of disease or describe the individuals who are the individuals affected at what place and at what time. So by the end of the descriptive study, we generate some hypotheses about the association between some exposure to certain risk factor and the outcome or the disease. In this lecture, we are going to always mention the terms exposure and outcome. The exposure mean the exposure to certain risk factors, and the outcome is the development of the health problem or change in the health problem. So by the analytical study, we are going to confirm this association or not by carrying out different analytical study to see if there is to test the hypothesis which we have already assumed by the descriptive study, and to see whether it is whether there is association between the risk factor and the outcome of the disease, also to confirmation of the hypothesis. There are large number of example of exposure and the outcome, which are always collected by taking different examination, different studies, and are involved in taking specific risk factor and specific disease. So the essence of analytical study is that group of subjects are compared in order to estimate the magnitude of the association between exposures and outcomes. So the analytical study, it is a comparative study. We always have two groups, and we are going to compare those individuals who have exposure and individual without exposure, and see if they develop the disease or not, depend on the type of the study. And we are going to discuss that point later on. But in analytical study, always we have two groups, or it is a comparative study, and we are going to compare between these two groups, not like the descriptive studies which we are going to discuss, and we are always taking one group. So by the analytical epidemiology, investigating a hypothesis about the cause of the disease by studying how exposures relate to disease. So we are going to study the relation between exposure and the development of the outcome or the disease. Before studying or before starting this analytical epidemiology, it is important to know some important terms which we are going to use frequently. First, risk. And I think we have already discussed that, but it is just to remind you that the risk is the probability that an individual will become ill or die within a specified period of time or age, and it is used to denote the incidence rate. So the risk is means the incidence rate. What is the probability of an individual who are exposed to certain risk factor who will develop the disease. The term the risk factor, it is a variable or factor associated with an increased risk or increase the probability of the occurrence of the disease or infection. Sometimes they call it is determinant of the disease also being used. So variable associated with either increase or decrease the risk factor. The risk factor refers to an aspect of either a personal habits, for example, eating habit, physical activity or lifestyle factors, smoking, alcohol drinking, drug abuse, or it could be environmental factor such as radiation or heat or noise or pollution, air pollution or water pollution, or occupational exposure. There are certain occupations they regarded as risky for people, such as doctors. They are at risk of large number of disease they expose during their occupation. The most important one is a cross infection, for example. And other factors, other risk factor, they are nutritional factors, different deficiency or increase in certain nutrient factor, also regarded as a risk factor in the occurrence of disease. That is associated with an increased probability of occurrence of disease. There are large number of risk factor. You can give a large number of examples for risk factor. Since risk factors can usually be modified, so certain intervention can be applied in order to reduce the income. So that's why it is important to know what are the risk factor for different health problem in order to put an intervention in order to modify the exposure and stop or change the outcome. The impact of this intervention can be determined by repeated measures, usually the same method and definitions. The risk factors can include tobacco, as we mentioned, alcohol, diet, physical inactivity, blood pressure, obesity, nutrition, environmental, and large number of risk factor. You can different large number of examples. Since risk factor can be used to predict the future of the disease, so their measurement at a population level is very important, because it is possible to measure this risk or the incidence of certain disease or predict the occurrence of disease in certain people who are exposed to certain risk factor. So it is important to apply certain measurements in order to alter the outcome. Another important factor is the relative risk. Relative risk is a measurement of the strength of association between an exposure and an outcome. If we want to measure how strong is the association between the risk factor and the outcome, we are going to estimate what is called the relative risk. So it is the value that it is an indicator of the significance of exposure and the etiology of the outcome. So the relative risk, it is a measure of the strength of association, and it is it's indicator regarded as an indicator for the significance of exposure and the etiology of the outcome, and it is calculated by relating the incidence rate among individuals who are exposed to the risk factor, and it is divided by the incidence rate among non-exposed. So the relative risk is a ratio. It is a ratio between two factors. So it is not a rate, but it is a ratio. The difference between the ratio and the rate, that in the rate, the numerator is part from the denominator and multiplied by a constant like incidence rate, infant mortality rate, or prevalence rate, maternal mortality, and all the maternal rates which we have already discussed. But the ratio, it is the ratio between numerator and denominator. The numerator is not part of from the numerator. So it is the relative risk is the ratio between incidence rate among exposed divided by incidence rate among non-exposed rates. So the incidence among exposed, they are not part from the denominator, which is the incidence among non-exposed. The value of relative risk depends on the difference in the incidence rates of the disease in the two groups, the exposed and the non-exposed group. And the value of it is very important to compare the value of the relative risk. So if the value of the relative risk is 1, so there is no association exists between the exposure to the risk factor and the outcome or the disease. While if the relative risk is below 1, so the factor may be, and the risk factor may be protective factor rather than a risk factor. And when the relative risk is more than 1, so then there is association exists between the exposure to the risk factor and the disease. And the higher the value or the greater the value of the risk factor, the greater is the association, and we are going to explain that or to explain that in another example. For example, if we have the incidence rate of lung cancer among smokers is 100 per 1,000, and the incidence rate of lung cancer among non-smokers is 20 per 1,000. So the relative risk equal to the incidence among exposed, or the smoker, which is 100, divided by the incidence among non-exposed, which is 20, equal to 5. So the relative risk is more than 5. So there is association between smoker and lung cancer. This means that the smokers develop lung cancer 5 times more than non-smokers. So the interpretation of the result is very important. We are not only dealing with number, but it is important to interpret the result. The relative risk is 5, means that the risk of developing or having lung cancer among individuals who are smoking is 5 times than the risk of individuals who are not smoker. Another important rate which we are going to estimate is the attributable risk. Attributable risk, it refers to the fraction of the incidence rate of the disease that can be attributed to the exposure to the risk factor. It means that what is the fraction of the incidence rate of lung cancer among smoker is attributed to smoking. So it is equal to incidence rate among exposed minus incidence rate among non-exposed. The significance of the attributable risk is that it gives us an idea about the expected gain in health and life, or the expected reduction in the incidence rate if the risk factor is eliminated. So it is important to understand the effect of prevention of smoking, how much we can reduce the incidence of lung cancer among smokers if we prevent smoking. So this is the significance of attributable risk, that how much we can reduce the incidence rate of lung cancer among smokers if we prevent smoking. So it is equal to as we mentioned, it is equal to the incidence rate among exposed minus the incidence rate among non-exposed. Another important thing is the percentage reduction, which is incidence rate among exposed minus incidence rate among non-exposed, or the attributable risk divided by the incidence rate among exposed multiplied by 100. This is called the percentage reduction. This explains the expected reduction can be expressed as percentage out of the incidence among the exposed. The attributable risk proportion as follows. So how much we can reduce the smoking by reducing smoking or prevention smoking among smokers. So if the lung cancer among smokers, as we mentioned, 100 per thousand, and among the non-smokers 20 per thousand, so the attributable risk equal to 100 minus 20 equal to 20 per thousand. That means 80 out from each 1,000 smoker, 1,000 cases of lung cancer, they are smoking attributed to 80 out of 1,000 cases of lung cancer. From each 1,000 of cases of cancer, they smoking is attributed to 80 cases. So the percentage reduction is the 80 divided by 100 multiplied by 100 equal to 80%. That means by the prevention of smoking, we can prevent 80% of cases. Prospective another important terms is prospective study and retrospective study. The prospective study, from its name, the pro in the future, it is a type of a study where participants are enrolled into the study before they develop the disease or outcome under study, and follow up for a period of time depend on the type of the disease which we are going to study to estimate the risk of exposure or the incidence of the disease after exposure. So we are following a group of people who are exposed to certain risk factor for certain period of time, and then we are waiting for the development of the disease, and then we are going to estimate how many individuals who are exposed to the risk factor will develop the disease or develop the disease after certain period of time. It depends on the type of the disease which we are going to study. While the retrospective study, we are going retrospectively. We are going backward. Individuals, they have already have the disease. Then we are going to study, or we ask about the whether they have been exposed or not. So the difference between these two studies, the prospective, we are going to or we are starting with healthy individual and following up these people for a period of time, and then we are going to estimate how many individual will develop the disease during the period of follow-up after exposure. While the retrospective study, we are going to start with individuals who have the outcome, and then we are interviewing them about the previous exposure retrospectively in the past. So the retrospective study looks backward and examines exposure to suspected risk or protection factor in relation to the outcome that is established at the start of the study. We are going to take individuals who have already have the outcome, have the disease. So another important term is the association. The association is the relationship, how much this risk factor associated with this disease. So it is either statistical quantitative dependence between two or more variables. So dependence between two variables. If the individual smoke, he will develop lung cancer, for example. So there is dependence. So the development of cancer depend on exposure to smoking, or individual who are exposed to asbestos, they have likely to develop asbestosis, for example. So it is a dependence or a statistical quantitative dependence between two or more variables are said to be associated if they tend to occur together more frequently than could be explained by chance. So they are frequently associated with each other or occur with each other. The degree of association is determined by statistical test. So the types of association is either statistical association or biological association. The biological association we have already discussed it previously, which is the Koch postulate. Types of statistical association, it is either causal or non-causal. Non-causal association when the apparent association is due to confounding factors, when a third factor is related both to the risk factor, the cause, and the outcome or the effect of the disease. So non-causal association, for example, coffee drinking and myocardial infarction. It is not a causative because there are other factors which may associated with the occurrence of the disease. Usually individuals who smoke, they drink coffee. So there is another factor rather than the coffee drinking which cause the disease. So it is a non-causal association. While causal association where it is either direct or indirect. The direct association where A as a cause or a risk factor, cause B as the disease. So, for example, vitamin A deficiency causes night blindness. So, direct effect. While the indirect association, for example, A produce B, then produce C. For example, vitamin D deficiency causes osteoporosis. Osteoporosis will lead to bone fracture or deformity, so it is indirect. The causal association, there are certain criteria for causal association, and this is which is proposed by Bradford Hill criteria, which are 8 criteria. And so in order to say that this factor is regarded or associated with this disease, it should have certain it should confirm the 8 criteria, Bradford Hill criteria, which is described by the following. First, strength of association, which is measured by the relative risk. The higher the relative risk, the more strong is the association between the risk factor and the outcome or the disease. Second, the dose-response relationship. The higher the exposure, the more or the higher is the incidence rate among exposed. The dose-response relationship, it means that the larger the dose or the longer the duration of the exposure, the higher of the risk of the disease. For example, we are going to discuss this later. Time sequence or temporality, where the exposure precedes the occurrence of the disease. Usually, the exposure before the occurrence of the disease. Experimental evidence, elimination of the risk factor reduces or eliminates the disease. If we remove the risk factor, there will be reduction in the incidence rate. Consistency, different studies have similar results regarding the association. Different studies in different countries and different population, it will give similar association. The coherence between epidemiological and laboratory findings increases the likelihood of an effect. However, Hill noted that lack of such laboratory evidence cannot nullify the epidemiological effect of association. Biological plausibility is the association consistent with other knowledge, for example, the mechanism of action, evidence, and experimental animal, and the specificity, the outcome of the disease occur only in relation to risk factor. Each risk factor is specific to a specific disease. So the strength of association, it measure of the association used to quantify the strength of association between the exposure and the outcome by the relative risk and by the odd ratio. The odd ratio, it is equivalent to the relative risks, and we are going to discuss it in the case control study. The strong association are more likely to be causal than weak association. The larger the relative risk or the odd ratio, the greater is likely, or the likelihood the relationship is a causal relationship. Weak association are more likely to be explained by undetected biases or confound. When there is a weak relationship or small relative risk, may be because of the presence of other confounding factors. So how large must a relative risk or odd ratio to be in order to be considered as a strong? 2, 4, or 20? No, actually no exact value we can depend on, but no universal agreement regarding what constitutes a strong or weak association, but an odd ratio or relative risk more than 2 is moderately strong, and odds ratio or relative risk more than 5 is strong association. So the relationship between smoking and lung cancer is an excellent example of a strong association. Odd ratio and relative risk in different studies are in the 4 to 20 range. So if these two ratios between 4 to 20, so this means that there is a strong association. As we mentioned, the time sequence or temporality, usually it explained by the exposure to the risk factor precede the occurrence of the disease. Usually, the exposure before the occurrence of the disease. For example, smoking for long period means that there is before the occurrence of the exposure, smoking before the occurrence of the lung cancer, or using any, for example, contraceptive, then the woman may develop breast cancer. So this refers to the necessity for the exposure to precede the outcome or the effect in time. Any claim of causation must involve the cause preceding the time presumed effect. Easier to establish in certain studies begun by prospective study cohort start with individuals who have no exposure, and then follow up for a period of time after exposure and see if they develop the disease or not. Lack of temporality rules out the causality. So it is important. So, as we can see, exposure to smoking after a period of time, the individual may develop cancer. Dose response relationship or biological gradient, the relationship between the amount of the exposure, the dose, how much the individual have a dose of exposure, for how long he is exposed, and then he will develop the outcome. The higher or the longer period of smoking, or the higher number of cigarette consumed, the more severe will be the outcome, or will develop cancer. If an increase in the level of exposure increases the risk of the outcome, this strengthens the argument for causality. So this is to explain the death rate from lung cancer by number of cigarettes smoked, according to a certain study in Britain. So you can see the biological plausibility. It reflects two things: the biological plausibility and the number of cigarette or the dose. Biological plausibility refers to the biological plausibility of the hypothesized causal relationship between the exposure and the outcome. If there is a logical and plausible biological mechanism to explain the relationship, there are different examples of different studies to show the association between, for example, maternal caffeine consumption during pregnancy and the risk of miscarriage. This is a prospective cohort study. A high dose of caffeine could constrict a mother's blood vessels, reducing the blood flow to placenta. This is a biological plausibility, and this is to explain why why abortion occur, because the caffeine it affect or cause constriction of the vessel of the blood vessel and reducing the blood flow to the placenta. This is called the biological plausibility. Sometimes there is no accepted biological mechanism to explain the epidemiological result. Indeed, the relation may be due to chance or confounding variable. The biological gradient is there, a dose response, how much is the exposure. So the biological gradient is the dose, is there, a dose response. That means it measures the dose of exposure, while biological plausibility, does it make sense? Does caffeine affect the vessel or constrict the vessel? While coherence, does the evidence fit with what is known regarding the natural history and biology of the outcome? Experimental evidence, are there any clinical studies supporting association? And reasoning by analogy, is the observed association supported by similar association? The consistency, repeated observation of an association in studies conducted on different population under different circumstances. The same result appear in while undertaking different studies in different population, different places. It will give the same result of association. If studies conducted by different researchers at different times, different settings, on different population, using different study designs, all produce the same result or constant result. So this strengthens the argument of the causation. For example, the association between cigarette smoking and lung cancer has been consistently demonstrated in a number of different types of epidemiological study, ecological and case control and cohort studies. Is there a causal relationship between fluoride in water and bone fracture? There are 18 studies have investigated the association between hip fracture, which is the outcome, and the water and water or fluoride level exposure. 30. Separate statistical analysis. 14. Analysis produce a positive association, while 13 analysis produce a negative association. 3 have no association. So there is inconsistency of these results. Cast doubt on the hypothesized causal relationship between fluoride and water in water and bone fracture. So there is inconsistency regarding the association between fluoride and fracture, fluoride in the water level, fluoride level in the or concentration in the water and the fracture of the bone. So there is inconstant association in different studies. The usual approach in epidemiology is to begin with a disease and search for its cause, although it is also possible to start with a potential cause such as air pollution and search for its effects. So there are two types of analytical study which we are going to discuss in the next lecture, which is either we start with the disease, with individual who have the disease, and then we ask retrospectively about the exposure to the risk factor. For example, we start with women with the breast cancer, and we ask them if they have already used the previously contraceptive pill. This is a retrospective study, while another way of studying is the association is also the prospective study, where we start with women who have or using who are now using the contraceptive, and then we are going to follow up them for a period of time. Then we look or wait for the outcome if they develop the cancer or not. Another example is social class is associated with a range of health problems. Low social class, as measured by income, education, housing, occupation, leads to general susceptibility to poor health rather than to specific effects. So, a range of specific causes of diseases could explain why poor people have poor health among them. So either also there are as a poor people or low socioeconomic living in low socioeconomic condition, they are exposed to the large number of infections or overcrowding, lack of clean water and sanitation, and lack of safe food, and they are living in unsafe environment or may exposed to large number of problems. So it is important to study certain risk factor and the association with certain outcome. And thank you.